Hello, and welcome to the presentation of our paper, A Qualitative Technology Evaluation Scoreboard for Digital Fabrication in Construction. I'm presenting this work on behalf of myself, Hunhevicz, René Jähne, Alexander Walzer, Fabian Seiler, Roman Wüst, and Daniel Hall. And this is research done at the Chair of Innovative and Industrial Construction at ETH Zurich. At ETH Zurich, we experiment a lot with digital fabrication in construction. Exploring these technologies is a great experience for everyone. But between stakeholders from research and industry involved in this kind of exploration, and as you can see in this image, we do building scales demonstrators, for example, where you bring together a lot of different people. You have the researchers, of course, but you also have engineers and builders, contractors, planners, and even a client. So between all these stakeholders, it can take a long time, sometimes months, to get on the same page about how the new dfab technologies work and which one to use for what purpose. So our thought was, how can we help generate a better mutual understanding of technology potential and user needs when working with digital fabrication? Or in other words, how do we bridge what's commonly referred to as the valley of death, where on one side you have universities and academia doing discovery and basic research, as you can see in the image on the left, where we have a robot printing, extrusion printing columns, and on the right, where on the other side you have industry and the market, where you need product development and production, and all of this needs to be market ready and responding to the needs of the market, as you can see on the right in a regular construction site. So we set out to develop a tool to bridge this gap. And we did this by qualitatively studying dfab technologies under development at ETH using interviews, process observations, and project documentation. And these are our research questions. First, what are properties of dfab technologies that matter for decision-making in industry? And second, how can these properties be generally described so that firms can evaluate, compare, and choose dfab technologies to invest in? Here you can see some of the cases we studied. We have technologies under development with FDM, also plastics printed formwork, where this is extruded into a formwork and subsequently filled with concrete, where special material technology is also applied. We have direct extrusion printing, which is what most people think of when we're talking about 3D printing in construction. There's also other technologies such as concrete slip forming by means of a flexible formwork that can vary the cross-section of, for instance, a column or some other linear building element. And there's binder jet printed formwork where 3D printing, in this case with a sand binder jet, is used to make large-scale formworks for concrete casting. But when we are looking at the entire process, it turns out that there are many steps that you need beyond the core dfab application. So you don't need to only use the 3D printer is not doing everything in terms of making the building part. So here you can see, for instance, that a 3D printed formwork is now manually sprayed with concrete to generate the actual prefab building part. And of course, there are other steps such as removing this formwork, which are also manual. So in basic research, it is most important to prove the concept, so these things don't matter as much. But for industrial application, all process steps matter. By analyzing the whole manufacturing process, we identified categories that are important to industry when considering investment in a new dfab technology. And here's what we found. It's a set of evaluation categories, actually it's 11 of them, that apply to several technologies. And these break down into 3 larger groups. The first group is the properties and addresses the question, what can it do? So these are things like freedom of design, so how many different things, geometrically speaking, can I make with this technology? What's the surface quality? In other words, how is the quality of the part that I'm making directly influenced by the technology I'm using? Multifunctionality, how many different functions can I integrate in a part that I produce? And structural properties. The second group is the resources. Responding to the question, what does it take to use this technology? In terms of time, in terms of workforce, is it highly automated, or are there lots of man hours required? What kind of material and how much do we need? And actually, very importantly, what kind of equipment do we have to buy and set into operation to use technology? And the third is manufacturing, which is sort of sits in between properties and resources, addressing the question, how does it work? Versatility in terms of how many different things can I make using a single technology? Scalability, can I upscale this both in volume and physical size? And how many steps are there in the production procedure? So how can we create a framework for industry to evaluate these categories? Or in other words, how can we help them answer the question, how can dfab help our business? Here we can see one of our industry partners who is currently dissatisfied with the processes at their disposal. So how can we help an industry, a company in the industry, in this situation with our tool? Companies considering dfab need a simple way to understand and compare the complex and developing dfab technologies available. So we took these categories we found and we developed a 4-point rating scale for each category to help answer this question. Here you can see one example. In terms of workforce, you have a rating from 1 to 4, where you either need have a very high demand of workforce, so it's highly labor intensive, or it's still labor intensive, requiring many manual tasks or supervision. Moderately high means that you need some manual tasks or maybe occasional or moderate supervision, and low would be fully automated with minimal supervision. And then applying these rating scales, which you can find in the paper for all of the categories, to a tool, this resulted in a tool that helps people in the industry self-assess the needs and compare the potentials of different technologies. Here on the left, you can see how a company self-assessed their needs. This is one example in terms of the different categories. Here on the right, you can see the self-assessment of the technology developers, showing the profile of 2 different technologies. And this at the end gives you a tool that will allow anyone in the industry evaluate their needs and then compare to the potential of different dfab technologies out there to get an early stage overview of possible dfab solutions and the potentials and trade-offs compared to the future users' needs. We see a lot of future research potential here. Right now, this research allowed us to develop only a very early stage perspective on evaluation categories important in industry adoption of construction dfab. But in the future, there's a potential to further refine this framework based on a more diverse sample of technologies, to quantify some of these categories, for example, productivity, to allow a more informed decision-making process, and to include sustainability parameters in the rating systems to reflect their growing importance in technology adoption decisions today. And with this, I thank you for your attention, and I'd be happy about your questions. Thank you very much.